We'll apply the same ideas in examples 4 and 5. We'll first take inequality 1, turn it into an equation, and solve for y to get y equals 1/2 x minus 5. And then do the same with inequality 2, giving us y equals 1/2 x plus 0. Something to note here is we have two equations with the same slope but different y-intercepts. So our boundary lines will be parallel lines, lines that won't cross over with one another. Looking first at equation 1, we have an intercept at -5 and a slope of 1/2. So we'll go up 1 and over 2. And then repeat that pattern. For equation 2, we have an intercept at 0 and then a slope of 1/2. And then if I was a little bit better at drawing, we would see two parallel lines, or lines that are on a trajectory to never intersect with one another. In cases like this, we only have 3 regions to consider, whereas in the previous cases we had 4. So we can consider test points of 0, -1, 0, 1, and 0, -6. So in the event where we have parallel lines, we only have 3 regions to consider. And in this case, the coordinate pair that will make both inequality statements true is 0, -1. So plugging that coordinate pair into our first inequality statement, will give us +2, which is less than or equal to 10. Substituting into our second inequality statement, will give us +4, which is greater than 0. So that point 0, -1 makes both inequalities true. So what we would want to shade would be that region bounded between these two parallel lines. Points above the second line or below the first line would only satisfy one of the two inequalities. In example 5, we can rewrite equation or inequality 1 as an equation, which would be y equals 5x minus 10, and rewrite inequality 2 as y equals -3/2 x minus 1. Graphing equation 2 first, we'd have that intercept at -1, and then a slope of -3/2. So we go down 3 and over 2. For our first equation, we have an intercept at -10 and a slope of 5, so we would go up 5 and over 1. And then we can again look at choosing test points. This time around, our lines don't pass through 0, 0, so we can use 0, 0 as one test point. We can also look at using 3, 0, 0, -2, and 2, -5. Again, we've selected one point in each of those 4 bounded regions, separated by the lines that correspond to our inequality statements. And this time around, it would be 0, 0. That would make both inequality statements true. Plugging 0, 0 in for both variables, or plugging 0 in for both variables in inequality 1 would give us 0 is less than or equal to 10, which is true. Doing the same thing in inequality 2 would give us 0 is greater than or equal to -2, which is true, meaning the point 0, 0 is in the region that contains all the xy pairs that make both inequality statements true, and we have this region that we want to shade to represent all of those solutions.